Hey peeps, it's Sophie from Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with Physical Science, the 2018 paper, question 4, on equations of motion. So, let's read the question. So it says two cars, A and B, are moving at speeds of 15 meters per second. This is car A, 15 meters per second, and 30 meters per second in the same direction. They are side by side when both drivers observe an obstruction ahead of them, as shown in the diagram below. So you can see this obstruction here. So it says both drivers apply their brakes and accelerate at minus 4.5 meters per second squared until both cars come to rest. Ignore the reaction time of the drivers. Okay, so the first question is a theory question, and it says, define the term acceleration in words. So acceleration is the rate of change of velocity. Okay, nice and easy. Remember, velocity is the rate of change of position, and acceleration is in the rate of change of velocity. They're the gradients of all the position time and velocity time graphs. Okay, so 4.2 says, calculate the time it takes for the car to come to rest, car A to come to rest. So this is an equations of motion question. So we're going to do it up here. So car A is the one going at 15 meters per second. So now it's important to look at what information we have. So I'm going to write given here. So we know that the final velocity is 0 because we're given that it stops and is at rest, comes to rest. We know what the initial velocity is, which is 15 meters per second, I guess to the right. And we know what the acceleration is, and that is minus 4.5. So it's important to note that whenever a car is slowing down, the acceleration will be in the opposite direction. So in this case, we've chosen to the right as positive, so the acceleration will be to slow the car down. It will actually be to the left, but because we're taking the right as positive, the negative sign is important here. Okay, so we know those. So the equation that comes to mind for me is the final velocity is equal to the initial velocity plus acceleration times change in time. Okay, cool. Then we can just plug everything in. So we know that's 0. We know the initial velocity is 15. We know the acceleration is minus 4.5. And we don't know the time. We need that stopping time. So then we can solve the equation, and we get that the stopping time for the car is 3.33 seconds. Okay, so it takes car A 3 seconds to slow down to a stop. Great. So now let's move on to question 4.2.2. It's kind of the same kind of thought process as 4.2.1 was, so let's just do it at the bottom here. So now it says find the stopping distance of car A. So you can do it using any equation, but I like to do it where you can rely with information you can rely on. So the information that they're giving you in the question is often the best to use in these problems. So they're asking for the stopping distance, so the equation that comes to mind for me is Vf squared is equal to Vi squared plus 2a change in x. And the change in x is what we're looking for. So we know what Vf is from here. We know what Vi is as well from just underneath that. And we know what acceleration is. We know that that's minus 4.5. So if you plug that all in, you eventually get an answer. Change in x is 25 meters. Okay, that is the stopping distance that it takes the car. And remember, this acceleration here is minus 4.5 because it is still decelerating. Okay, so let's keep those answers in mind. Let me just erase some of this while we move on to 4.3. Just make some space here. All right. So 4.3 says, which car, A or B, has the longest stopping distance? Support your answer with a calculation. So intuitively, it's kind of seems like it's going to be car B, which is probably going to be the correct answer because car B is going faster. You know, if you're in a car that's going faster, it's going to take you a longer time to slow down and stop. But let's do the calculation anyway. So we can do it the same as we did it previously. So let's just first write down what our stopping distance for car A was. So A, stop, that was 25 meters. So let's try this. So let's do just for car B because we know that what car A's stopping time, well, stopping distance is. So let's just do the same thing as we did in 4.2.2. So we're going to say VF squared is equal to VI squared plus 2A change in X. So we know this for car B is 30 meters per second. Oh, no, it's not 30 meters per second. It is 0 meters per second because it stops at rest. This is 30 meters per second. Sorry about that. And then A, they accelerate at the same rate, so that's minus 4.5. And in the same way, you can get your stopping distance to equal 100 meters. Okay, so that's kind of proven what we said initially, is that if a car is traveling faster, then it's going to take a longer time to stop if it's accelerating at the same rate. And that's what they're asking you to explain in question 4.4. So they say, what conclusion can be made about the relationship between speed and stopping distance? So as we said, if your acceleration is the same, then a larger speed would take a larger stopping distance to come to rest, which can be proven with this whole calculation that we've done here, as well as in 4.2.2. So same acceleration means a faster speed slows down slower than at a slower speed. It stops in a longer distance. So yeah, that is question 4 of the 2018 physical science paper. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. Be sure to visit the website for more of these epic tutorial videos. And if you can't find the answer that you're looking for, you can send us a question and we'll respond with a personalized video just for you. So until next time, stay epic.